Good morning. I have a video of the simplex method. In fact, I have several of them. They are a little lengthy because, well, it's a simplex method and takes a while. I did want to show you how you could do this with a calculator. Unfortunately, you can't just plug in a bunch of numbers and hit a key and get the result. You do have to go through a process, and so I'll walk you through that process right now. And I've basically written down the things that I would think that anyone would need to write down in order to get started. But the first thing is we solve the linear programming problem using the simplex method. We want to maximize p is equal to 30x1 plus 40x2. That's the objective equation. Subject to the constraints, 2x1 plus 2x2 is less than or equal to 50. X1 plus x2 is less than or equal to 35. X1 plus 2x2 is less than or equal to 60. X1 and x2 are greater than or equal to 0, meaning they're positive because we are talking about probably some kind of profit or something. First thing we need to do is to adapt the linear programming problem to a system of linear equations by introducing slack variables to convert the constraint inequalities to equations. So essentially what I'm doing is if 2x1 plus x2 is less than or equal to 50, then there's some number that I can add in there to make it equal to 50. So we just call it s sub 1 for slack variable 1. And then x plus 1 plus x sub 2 is less than or equal to 35. There must be some unknown quantity that makes it equal to 35, so we use another slack variable or introduce a new slack variable, s sub 2. Likewise, x sub 2 plus x sub 1 plus 2x sub 2 plus s sub 3 will equal 60. And then we solve the objective equation for 0, meaning that we just subtract whatever's not on the p side from both sides to get negative 30x sub 1 minus 40x sub 2 plus p is equal to 0. And then I've just listed the constraints because now that we have those new variables, they're also going to be positive. Although this doesn't come up in the simplex method, I guess it's just a way to check and to be correct. Anyway, now we need to make the initial simplex tableau, which is a matrix. Now when we put in the calculator, we will not have this variable row. This is just to kind of keep track of what the columns represent. And I'm not going to change, I don't do that changing stuff. Some people do. We're just doing the simplex method. But anyway, I put in the matrix just normally the way we are. Normally the way we would make an augmented matrix with a system of equations, we just list the coefficients, and the coefficients of where variables aren't, then the coefficient is 0. And anyway, I already put the matrix in there. If you need a review of that, you can go back and see the video where I put the matrix, but for interest of time, I already put it in there. I put it in location A. It's a 1, 2, 3, 4 row by 7 column matrix. I like to check it, so I'm going to call it up into memory and then hit enter. And I have 2, 1, 1. Excuse me. I don't know if you heard that. Shouldn't have done that. But anyway, drank some coffee. 2, 1, 1. 0, 0, 0, 50. Looks like my first row is right. Second row is 1, 1, 0, 1, 0, 0, 35. Looks like my second row is right. Third row is 1, 2, 0, 0, 1, 0, 60. Looks like my third row is right. And my fourth row is negative 30, negative 40, 0, 0, 0, 1, 0. And it looks like I got that right. So now we're going to do the first row operation in order to do the simplex method. Now, in order to do the first row operation, we first have to select the pivot. In order to select the pivot, we must select the pivot column. We select the pivot column by looking at the last row, the objective row, if you want to call it, because that's where it represents the objective equation. And we select the negative most number. Well, in this case, it will be negative 40. That means that the x2 column, the initial pivot column, will be the second column of our matrix. And now to select the pivot, or the pivot, we select the pivot row by taking the numbers in the pivot column and dividing the right hand side number, or the quantity, the rightmost column, by that number in the pivot column of that row. So 50 divided by 1 is 50, 35 divided by 1 is 35, 60 divided by 2 is 30, and now the pivot will be the intersection of the pivot column and pivot row, and the pivot row will be the row that has the least value when I divide the number of its pivot column by the right hand side number. The right hand side number by the number in its pivot column. It's a mouthful. 50, 35, 30. 30 is the least of those values. Therefore, our pivot will be 2 in this case, which will be in row 3 and column 2. So now we need to make that into a 1. That will be our first task in our simplex method. Now that we've got our pivot. So what do I need to multiply 2 by to get a 1? 1/2, of course. So now we're going to use the multiply row function of our calculator, and I actually have the instructions detailed down here, the syntax in which you must input it. So I'm going to go to matrix, I'm going to go to math, I'm going to go get the multiply row, it's E, it's got the little star row, parentheses, and now this is important the way you put it in. I'll first put my non-zero multiple. We've decided that's going to be 1/2. We can put it in as 0.5, or we can put it in as 1 divided by 2. Doesn't matter, calculator will be happy with it. Comma, the matrix name, so I must go into the matrix menu, grab the name, and then it'll be A because that's where I put it, comma, and then the row I'm going to multiply, I'm going to multiply row 3. And then I want to close the parentheses. Now I could just hit enter, it will do what I need it to do. However, I want it to store the matrix, the operation in there, so therefore I can look at it again. Now I can store it in a new matrix location, or I can store it into the matrix that I already have input. I'm going to put it in A because I just like to leave my matrices, that way I don't have to keep track of which matrix I stored it in. So I'm going to hit store. Before I hit enter, go to the matrix, select the matrix again. You can put it in B if you want. I'm just going to overwrite A, and then hit enter, and there it did it. And there I have all of my, there's my first step of this simplex method. Now, if you wanted to, for whatever reason, you can go to, if you want fractions, you can go to math, and sometimes my math lab asks you for fractions. Usually not at this step, it's usually at the end, but you go to math, fraction, and notice it'll convert all the decimals into fractions for you. Anyway, now to get zeros, so now we have our pivot, which is this third row, or first pivot is our third row, second column position, and it's this 1, and now we need to get zeros in the pivot column. So we need a 0 here in the first row, second column position, a 0 in the second row, second column position, and a 0 in the fourth row, second column position. And to do that, I'll use a row operation, particularly the multiply row add in each case. So I'll have to do 3 operations. So in order to get a 0 in the first row, second column position using the third row, second column position, I need to multiply row 3 by -1 and add it to row 1. Likewise, to get that 0 in that pivot column position on row 2, I need to multiply row 3 by -1 and add it to row 2. The reason is -1 plus 1 is 0 in both cases. Now to get a 0 where this -40 is in the fourth row, second column position, I multiply row 3 by 40 because 40 minus 40 is 0, and then I'll do that. So let's get that done, and we'll store the matrix in each case. So this is why I was saying it might just be faster to do it by hand. But anyway, I'll do it in order. So I go to matrix. Now I want to go to math, and I want to get the multiply row add. And now I have the syntax here. First, the non-zero multiple, you must need the -1, comma. Now I put the matrix in, which is A, and then comma. And then I want to do this to row 3, and I want to add it to row 1, close parentheses, store. I'm going to store it matrix A. By the way, if you do it this way, you have to go in order. In other words, I can't go and do more operations because it's storing it at each one. So there's my next, that gets me that 0 there. Now we'll do the second row, second column position, get that 0. So we'll go back to matrix, go to math, multiply row add. Essentially it was the same row operation, we're just changing row 2 now instead of row 1, comma, go to matrix, get my A, comma, I'm multiplying row 3, adding it to row 2, close parentheses, store it as matrix A. Let's see if that worked. Yep, I got 0, 0, and then 1. I'm not going to change it to I'll do that at the very end because I think that my math lab does want it as integers or fractions. Now to get this 0 here, we'll go Go back to matrix, multiply row add. Now we're multiplying row 3 by 40 of matrix A. Oh, I didn't hit that. Let's clear that. Delete, 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 delete. We're going to go get matrix A, comma. Now, if you don't store it every time, you know, this won't work. You have to store it after each operation. Now we're multiplying row 3, and we're adding it to row 4, close, and then store matrix A. I know this is kind of weird. That's why I don't make these, because they're kind of boring. But anyway, and now we've have our new simplex. So now we're ready to select our pivot for our second iteration of the simplex method. So again, we do it the same way. That's why we call it iterative process. You just do it over and over again. It's the same process. Once you get the steps down, it's really easy. You're just doing the same thing over and over again. So we look at the last row and we choose the negative. Now we're done with all of this over here. Now we're just looking at the calculator. We look at the negative most value. It looks like it's negative 10. That gives us our pivot column, which is our first column. And now I am going to convert this to fractions, and I didn't need the second because I do fractions. Fractions are easier to work with. So now I want to, you know what? Enter. Oh, I thought I could. Okay, there I can scroll through there. I was just making sure that we can't. I'm going to divide, our pivot column is this negative 10. I'm going to divide each number from our pivot column to its right hand side pivot row. So 20 divided by 3 halves is going to be 2 times 20 is 40 over 3. 5 divided by 1 half is 10. And 30 divided by 1 half is 60. So it is down between row 2 and row 40 divided by 3 would be, what would that be? 40 divided by 3 would be something around, it wouldn't be 15, it would be 14. Well, let's just do that. 40 divided by 3 is 13. So the 10 is actually going to be our least of our values. So when we divided 5 by 1 half, we got 10. 40 over 3 is greater than 10. So our new pivot is going to be this row 2, column 1 position. What do we need to multiply this 1 half by in order to get a 1? We need to multiply it by 2, of course. So we go back to matrix. We go to math. We go get the multiply row. It didn't give that to me, so let's clear that out. Okay, so I think I just was in there. I got to go to math, multiply row. We're going to multiply it by 2, comma, matrix A. This is why I would really suggest writing this down, because otherwise you got to go up here. I think that was row 2. And then we'll store as matrix A. And there we got our 1. And it left everything the same. I was just making sure with all that bumping around I did. So I would really encourage you to write down every step, because otherwise you're going to frustrate yourself just as much. The calculator solves your math errors, but doesn't really, if you don't put it in there right, it doesn't do it. So now I want a 0 in this position, a 0 in this position, and a 0 in this position. I need to multiply row 2 by negative 1.5 and add it to row 1. I need to multiply row 2 by negative 0.5 and add it to row 3. And I need to multiply row 2 by positive 10 and add it to row 4, and that will get my zeros. And I think at that point we'll actually be finished, but let's see. So I want to go to matrix, multiply row add. I'm going to do the first row first, so I'll multiply negative 1.5, or you can put 3 halves, comma, of matrix A, comma, and I'm going to multiply row 2, comma, and I'm going to add it to row 1, and then I'm going to store it in matrix A. And I'm going to hit enter, and there's our 0. And now I'll get that 0 here in the third row, first column position, by multiplying row 2 by negative 0.5 and adding it to row 3. So I go to matrix, multiply row, add. I'm going to multiply it by negative 0.5, comma, of matrix A, comma, row 2, comma, adding it to, I don't know why I did the second, adding it to row 3, close parentheses, store into the matrix A location, and that gave me my 0 here. Now just to do the fourth row, first column position, so I'll multiply row 2 by positive 10 and add it to row 4. So I go to matrix, multiply row, add. I'm going to multiply it by 10 because this is a negative 10. 10 minus 10 is 0. In matrix A, multiply row 2, add it to row 4, store it in matrix A, and hit enter. And now I don't have any more negative values in my fourth row, and therefore I'm done. The simplex is finished, and the maximum value of P is 1300. Now x1, I look for the x1. This was the x1 column, so here's x1. What was its value? It was 10. And then I look for the value of x2. That will be on the third row because I have the x2 right here. And what was its value? It was 25. So the maximum value of P is 1300, and the x1 value is 10, and the x2 value is 25. And that is it. I hope this helps. You're more than welcome to do it by hand. In fact, I think it's easier to do it, but I figured I would show you how to do it on a calculator. And that's it.